Okay, welcome back. I am back and we are still solving the same problem. So, as we were looking at it, I did come across an idea for this. If n is less than or equal to 1, we simply do nothing. Right, we simply do nothing. Now, when I run this thing, let's just clear the output. And when I run this thing, now it will give me, at the beginning it will be nothing, right? Okay, it is still adding this thing up. So what's happening over here again? So 2, okay, it's coming inside 2 and then it's going there. This thing is 2, it's not finding it, isn't it? No, it's going to be 2 and then 1 to 2. It will run once, right? And then what will happen is that it will run there, and this thing is what, 2 at the moment, right? So when it comes in, it will be 2, and then over there it'll go over here, it will be 1, and then that will be 1 minus 1 0, so 2 plus 1, that will return thing. So I don't need to pop it. Why am I even popping it out? Okay, in the beginning it's going to do that. Now it's much better, right? So I think without the popping thing, without the pop, it should work with, so if I had put in 1, so there is already 1 over there, right? 0 and 1, so it will have to start from 2 itself, nah? That's what I'm guessing it to be, huh? 2, if it is less than or equal to 2, it will have to return nothing. Now when I run this thing, it will be 1 to 2. Alright, so Fibonacci sequence. Okay, what is that? It is printing out to be that much, so it's adding up thingy. 2 is going inside, it's 2 to 2, 2 to 2, it's not doing anything, is it? It's not. Print this, let's do it, it's giving out this 3, and then 3 is being added over here, the sum of it is going to be 3, that's what is being printed out, and then n will be, n is already 3, it's coming over here, so 2 to 3, it's not getting anywhere, then it will have to, since it's going to be out of range for that, so shut the door. Right, okay, so even then it's not going to work. So if this thing were to be 2, right, so 3 2, then it will be what, 3 2, it will start from 2. Now what will happen? Okay, 1 2, that's it, that's what I expected. Okay, now the sum is 11. So since we are summing it up after this thing, right? So I could do like total sum is greater than the number. Iteration of sum will be, let's say, 10. That will be iteration underscore sum if uh, total sum is greater than iteration sum. I could redo the sum, right? So total sum equals to sum after popping this thing out. After Fibonacci sequence dot pop. Now when I do this, it should I'm expecting it to run. It's not iterable. Okay, so pop will give a int. Okay, it's just going to give that that's not going to work for us, so I could simply do this over here, right? Over here, Fibonacci sequence. Now when I run this, does it work? 11, it's already here. The sequence is coming out to be fine. What is this going to be? It's going to be 11, then it's going to be that, but it's not looking at but why are you going over it? That's my concern. Okay, in the second loop it's coming over there, and then it's going to pop out the 6 from there, then it's going to do that, right? So I can't do it for that. I can't pop out because that's going to affect the list, as you can see. Alright, so if I were to do 15 over here, that should not affect my original list. Ooh, what is this? Three came about, so this first one was what, 2, I guess, right? So it was 2, and then it went inside. Yeah, it went inside, it did not do anything, it came out, and then after that went for another iteration inside, +1, and then until then the sum was what, when it was 1 and 2 it was 3. Okay, great. And then in the next iteration it was 3. 3 went inside, and then it was from 1 to 2, and then 1 to n, and it was what, 3 at that moment, right? So 3 was over here, but 3 is not there. 1 to 3. Okay, it came out to be 1. It's not going to work, is it? I will have to redo this thing. I will have to redo this thing. Let me just comment that thing out. Let's see. Fibonacci, and let's go 5 iteration here, and let's print the Fibonacci sequence list without doing anything. If this is okay, then everything will be okay. Working fine for that. For 10, let's see. Okay, 1 2 3 4 5 6 7 8 9 10 11. Okay, don't even need this, I guess. It is required, but I want to do it a little bit like that. If it's going to be from 0, then it's going to find it's not going to be anything, right? So it's going to be 0 over there, that is there, 1 minus 1, it's going to be 0 again. Is it will have to start from somewhere, right? I think with 1 this thing works just fine. 2 is already there, so it's only doing from here to here. So from here to here. So it will only have to go from 2, isn't it? Right, 10 is coming here, it's going over there. So 2, and then 2 minus 1 is 1, 2 itself, it's not going to be there. So that's why it's going to throw out an error. 1 2 3 4 5 6 7 8 9 10 11. I just don't want that. What if I do n minus 1 here? That's going to mess up everything, or is it? Because I want it to go up to that iteration only, right? Okay, what if I do 2 here? Now, what will it do? It's doing that. Okay, 1 2, that's fine. Great. 3, that's what I want. We want 2 3 4. Okay, 4 1 2 3 4. I want it to be 5 iterations. Okay, that should work, because what happens is, you see, if I do 2 from here, right, so 0 and 1 is already there, but if I do 2 from here, it's not going to find 2 over there, right? So I have to think from the index perspective over here as well. So that's why I'll start from 1. I'll decrease this, but I will have to decrease that as well, right? I could probably do -2 here. Will that work? -2. Will that work? Will that work? It won't work, because that will be decreasing. 5 minus 2 will be 3. 3 will not be there. Okay, 3, and then 3 will be there once it is running, right? So 0 will create this, then after that it will be what? At the initial stage it will be 5 minus 3, right? So 3, so first it's going to run at 0, right? So when it's running at 0, it's going to do basically nothing. It's going to add 1 plus 2, right? So that's why it's working. It's going to add this, and then -1 is in the list. It's the other one, it's the ending one, right? So that's why it's going to be 0 plus no, at iteration 0 it's going to do first number will be 1 plus, let's just do sum here. The number will be 1 plus 2, because the last number will be that, right? So it will be 3. Then after that it will iteration number 1. Iteration number 1, it's 1 now. Now what's the sum? So sum will be 1 is 0 and 1 is 2, right? Plus 2 minus 1. What is 2? What's the list now? The list will be 1 comma 2 comma 3, right? So what's the list now? We are running at iteration number 1. Is it? I is 1, so 1 is already there. Okay, iteration number 1 will be 0 1, that will be this 2, right? So that's coming already over there. 1 minus 1 will be 0, so 2 plus 1, this will be again 3. That's not what we want, is it? That's why we are getting this. So the correct solution for this will be, we start at 1, but we subtract this by 1, so that we compensate for the extra 1 that we are losing. Since we already have 2 in the list, we compensate for that. What if I do Fibonacci sequence to this? Will this work? Yeah, the range, blah blah blah. 5 is there, it's coming from there, and then it's going to be 2 directly, right? 2 directly. So 2, it's not going to find it. I will have to do -1 here, I guess. Yeah, that will also work. Look at that. We will be solving this problem, but we won't be solving the other problem of n minus 1, right? So we want it to go from go for 5 iteration, right? But since we have already done 0 and 1, we want it to go for up to 3 after this, right? So up to 3 means it will have to start from 1, but it will have to go until 4 only. Yep. 1 2 3 4 5 6, not that. I will have to relearn it. Okay, now it's looking good. Anything in the chat for now? Okay, now as you can see, 2 is already there, 5 and 4 will be coming in. So 1 to 4, how many iteration will it do? 1 to 4, then it will do what? 1 iteration, 2 iteration, 3 iteration, 4, no, only 3 iteration. That's how it will work. Alright, so we don't want it to iterate from for 0 and 1. We want it to iterate. It's like a little bit confusing over here, because why is that? Is we should not want it to start from 2, otherwise we'll get an index error over here, right? So what we actually want to do is that we want to start from 1, but we just don't want this thing to go to negative as well. So that once it starts adding it up, there will be values over there. That's what I mean. So anyways, this is perfectly fine now. Now it's perfectly fine, right? Now I will comment this thing out. This thing is perfectly fine. Let me look over this. Okay, let's do this. Oopsie, oopsie, oopsie. What did I do? I did not do total sum. Total sum is 0, which is always less than that. Terminate. Total sum. Where did it go? It should be here. And I do this. Right. Okay. So I will run this in my terminal. Create new terminal in the site. Hmm. 1 2, because 2 is coming here, 2 minus 1, it's not doing anything, it's just printing out the list. Okay, and then after that it's adding it up. The sum of that will be 3. It's just printing it out, and then it's going back. It's going to be 3, and then 3 will come in. 3 minus 1 2, the list gets build up. That's good until there. 3 is doing fine. Then it comes up to 4. 4 is coming over here. 4 minus 1 is 3. So we are somewhere here. This thing is already built. So 3, no, 2 is already there. 3 is there. 4, right? So we are coming at 4. 4 minus 1 is 3. 3, that means it will go up to 1 and 2 iteration, right? So when it is coming back for 1, it's going to be 1 and then that thing. That's not going to work. right? Because that will mess up everything. We don't want it to loop over the counted numbers, is it? We don't want it to start from that number again, is it? So we don't want it to start from that number again. So we would want it to start from so when it is coming here, it's 2, right? It's 2 here, it's 3 here, it's 4 here. So we want it to start from 0, 1, 2, 3. Okay, n minus 1 is doing that, but this is always I, right? So it has to be n minus 1. We are doing it over here. That means it will have to be a little bit different. It will have to start from that number itself. So 2 is here, 3 is here, this is 4, so we don't want it to go from here. Sure is there, 3 is there, 3 minus 1 is 2, it's just going to run for once, that's fine. 3 minus the length of that, length of this is 2, okay. Okay, we want this thing to be can't do that as well. Length of 1 minus length of this minus thing as well, it's not doable. Maybe it will work if I add 0 in over here, 0 comma, but I'm not sure. Okay, let me keep the solution as it is for now. Copy this thing down somewhere here. Right, our working solution is over there. So what I'm going to do is going to comment this line out, going to add a 0 here. Let's do this. So I'm going to make it a little bit more dynamic. Fibonacci sequence, right? So that will increase every time. So if it is 1 or 2 until 2, it will just simply return, right? So after that, what will happen? So when I do this thing, so if it is 3, right, so let's start from 3, it's coming here, length of this is 0, 3, right? So 3 minus 1 is 2, it's not going to do anything, I guess, is it? Let me just run this thing. What the hell is this? What the hell is this? Why is it printing out that? Weird. Ah, okay. I did not give this to the memory, that's why. 0, 1, 2, that's what I expect. Okay, that's fine. When I give it 4, what will it behave like? Okay, when I give it 4 as well, 4, it's going to come there, it's not going to run, is it? 4, why is it not going to run? It's coming there. When it is 3, it's going here, the length would be 1, 2, 3. Okay, 3, 2, 3 minus 1, that's not going to run. Okay, that's fine. 3 is not going to run, that means this will be affected, I guess. So 4 will be coming in, it will still be 3, and then 4 minus 1 still be 3, right? What if I do this? It will probably run, but it's not the ideal solution. It will run, that's for not sure. So 3, right? So 3 going here, length will be 2, and then 3, it will run over one iteration. 3, so 1, 2, it's not going, it's going to be a error right over here. Let's just see that error. Oopsie, it did run. How come it did run? It did run, it did run, it did run. How come? That's my concern. How come it ran? 3, right? When I do this, it's not going to do. Okay, 0, 1, 2, 3. 3, right? I decrease this thing. 3 minus 1 is 2. This will be 3, and 3 minus 1 is 2, right? So 2, and then 2 minus 1. So okay, so 2 this was that. It's going to be 3. Okay, when I do 4, what will happen is that 4 minus 1, so when it comes to 4, the list would have grown to 0, 1, 2, 3, 4. 4 minus 1, 3 will be there, and then 3 to 4, it will simply run for one iteration only. Okay, great. I think that's what we would need over here for this particular sum anyway, right? So we don't want it to repeat, because we don't want we don't want the loop to start over all over again. So list minus 1, and then that times, right? And then at the end of it we can pop it out. Looks like a good solution to me. It should work now. Okay, let's go. 15, right? So total sum. What if I do this? That's what I want, is it? I don't need this, I guess. Now when I run this thing, it's going to be 1, 2, 3, 1, 2, 3, 1, 2, 3, 5. So 5 and 6 is 11. Okay. Oof, it messes it up over here. So here what happened is it did pop. Just need to break somewhere, I guess. 93, 1, 2, 3, 4, 5, and when it is greater than that, it should not sum. It has already summed it. Right, what's the Fibonacci number? That's all we need to do. Right over here, the sum is 10, 11, and then 8 is already 19 over there. Right, we would want it to break somewhere here. Pop it, and then it's giving out the sum. Okay, the printing is coming from there. I don't need the printing there when it is this, so that we know where it is popping out, and then after that we calculate the sum, and then we break out of this loop. That's it. 1, 2, 3, 5, right? How many iterations did we do? When the sum is 15, less than 15, so 5 plus 3. will be 8, 10, 11. Okay, that's fine, but when it is what? When we add 8 to it, it's going to be 19. Okay, great. Great, great, great. 23. Okay, let's just do this. Do this. Should work as well. Not supported. Tuple. No, I don't need this. I need this. Will this work? Okay. Okay, I don't need to sum it like that as well, is it? Okay. After it has generated everything, the loop is broken. I get the total sum, but I don't need the total sum, do I? I don't need it, I guess. So among the 15, right, among the 15, I only need the sum for that, right? So my list is ready now. My list is ready now. So now at the end of it, if I will have to do one more iteration for this, or my total sum should be somewhere below. Right. So once I have popped it, I don't need to sum it over here directly. If I will need to kind of put a condition over here. So if Fibonacci sequence, I will have to do a loop over here for I in. I did not even have to append it, right? It will have to create a list first, and then it should not disturb the list. It should be at the very end of it. It should not disturb the, otherwise if you start popping this thing up, it's going to disturb the whole list. That should not happen. Okay, let's just put it outside so that it's more readable as well. So if for I in range, no need to do Fibonacci sequence, and if I is perfectly divisible by 2 equals 0, then what we do? Print. No. For this we will add some even sum equals 0, even sum equals 2 plus equals to I. That's it. And when I go here, print even sum. I could start popping it out of the list. That's doable, but still 2, right? That's it. Zero, 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 zero. Let's run this thing. Okay, that's the big number. Fibonacci number, check. 1089154. Oops, incorrect. Go back to the problem. Let's see. How is it not a solution? If it is not equals to 0, I will simply pop it out. I will need the index, right? I think I can do some indexing over here now. work? Yeah, integer has no pop. Let's just create a new list. Even let's start append I. Why is it 0? Should not it be something? I'm like, why is it not giving me list? Okay, 0 and 2. Okay, now. Let's do 100 for now. Let's test it out in bigger numbers. Is it just that much? Looks like it. Looks fine to me, or am I interpreting the whole question mistakenly? That's the only concern. Okay, when I'm doing it 1000, the sum of this will be 985. That seems about correct. There is no doubt about that. Sum will be also correct. Right. So even we were to do 3, 4, 5, 6 for 1 million, it's still correct, isn't it? Yeah, because if we were to add that number plus that number, it will be 196, then it will be 2 million. It will be more than a million, right? Okay. 2, 8, 34, 144, 610, 2, 2584, 10. The jump is like what? Exponential, huh? Is there a pattern though? 4, maybe not. What am I doing wrong? Looks about correct to me. What does it say? Do not exceed. So what is it? Less than or equal to? What if I do that? Let me check for this particular problem. 11. Okay, 6. For this problem, 8, 10, 11. Okay, 0 and 2 will be there. could just handle this thing as well. If 0 not don't add in list, I'm not going to bother doing that. Just going to put something here. Total sum here. First it's going to be 3, then it's going to be 6, then it's going to be 11, then it's going to be 19, right? Before we pop it, we will have like what, 9 as well in the list. No, 8 as well in the list. Okay, that seems about right. So 4 million. Let's see. It should work. 1, 2, 3, 4, 5, 6. Print sum of even list. That's what it is, isn't it? How come? How come? How come? Is it like that number should not be 1, 2, 3, 4, 5? So that's not even 4 million, is it? That seems about right. The way I interpreted the question, and I did it. Am I interpreting this correctly though? Let's just ask ChatGPT now. There is no question, no thing to it. So this is my answer. For this, do not provide answer or code. Saying values, not the sum. Okay, maybe it's saying that. Right, so how do I make sure that I don't mess this thing up? Let's just create another problem to a.py. Let's copy the whole dang thing. Let's paste it here. Okay, now I will need to look at the list. Right, so this is my list. It's doing all right for whatever iteration it is doing. So it's not going to be the sum, it's going to be the list values, the last values in the list. That should be less than that. Okay, so Fibonacci sequence dot index. Okay, I don't need a -1. I think that should be less than it should be value figure, I guess. So it will have to continue. Da, 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 da. If it is da, 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 it will continue. How much will it run for? Let's see. I don't need the sum of this thing as well, is it? I don't need the whole dang thing. I will simply need to prepare the list first of all, I guess. Right. Okay. Let's do something like this. Home. Da-da-da-da-da. That's going to be an infinite loop if I don't close it. So once that thing runs, it's going to be thing, and then it's going to prepare the list, right? So if Fibonacci sequence dot well, that is less than that, it's just going to continue. Okay, you won't need to do anything, I guess. Da-da-da-da-da. Still doing the same thing. What if I have this thing to be the value should not be 15, and that should not come in, is it? Ah ha ha ha, what a dumbo. I should have ran it in different terminal. Python problem 2a. Okay, this is not correct. This is not correct. Why is it stopping there? That's it. It's doing all right. If I do pop over there, it's going to do that, right? So that condition is still valid, I guess, this one. Right, it's going to add that, it's not less than that, so it's still doing it. And then if value figure is it's not testing, if this thing -1, I think my design of it, this thing is a bit here and there. Anyway, pop. Don't need the sum. Don't need that. I just wanted to do that much. Okay, great. Now this is going to be the same thing. 10, right? Okay. 1000. Let's test it out. Ta-da-da-da-da, ta-da-da-da-da. Great, 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 great. 4. And let's go up till million. 4 million. Let's go. That's the number. Perhaps. Okay. Shush. Check. 4613732. Woof! Congratulations. Congratulations. Hmm. Okay, private discussion problem 2. Five, five, five. I don't know how these guys are doing it. Haskell, blah blah blah. Temporary variable. Hey. Why is this thing not going? Okay. 9 somewhere here, 2024. Great. Great. Just doing something over here. Okay. A is 0. Right. Sum is there. B equals to B. A plus B. Okay. Then it's going to come at 0, right? 0. It's not going to work. 0 plus 1, 0 plus 0. I went a bit different route, but that's fine. Seems to be working. But a lot of this code is rudimentary, that's for sure. Mm-hmm. The last sequence in the list is this. All we need to do is just generate the list. Went a bit longer way. That's fine. Whatever rocks the boat. Individual value should be less than that. Okay, great. Anyways, that was a great problem. Let's delete this thing. Deleted. Yes, I want it to be permanently deleted. Let's make this problem 2. Problem 2 is done. Problem 3.5. Problem 3 is what? Problem 3 is largest prime factor. I'm not going to show the solution. Prime factor of this. What is the largest prime factor of this number? Okay, I will have to look into it. Let's copy the question first of all. Let's paste it here. Let's go to home and let's do this. Let's find slash question mark come. It could come, it might not come. Alright, we do that, we replace dollar. Alright, I escape character there. Oops. And get rid of the thing as well. Okay, got it. Great. Now, what else? factor. What is the largest prime factor? Okay, let me just pull up the feed here as well so that I know what's happening down there. Simply go here and go here. Go. It seems like my terminal theme is not so good, huh? So what should I do? Dark modern looks a little bit grace on the eye. This looks fine. Visual Studio Dock. Clear. Okay. What are the prime factors of this thing? Okay. So first of all, I will have to look into prime factors, prime numbers. Right. And it should be any number that can be divided. It will only be divided by 1, otherwise it won't be divided by any other number or 2 or 3. Right, okay. Let's generate some prime numbers first of all. So define prime numbers. So let's generate something. A equals to a list of prime numbers. So let's say this is n, and for I in range up to n we go there. If I equals 1, we simply return, we simply pass. If it is 2 as well, you don't even have to do this. And if I is divided by 2 or 3, is divisible by 2, or I is divisible by 3, it's going to be a prime number, is it? That happened I here, right? Basically. I can just put this inside, I guess. Print prime numbers up to what? 10. There should be only 1. Pass. It will have to be somewhere here. Return does not work. Okay, that's done. I will not pass. Continue. Right, should not look down. If I equals 1, we will continue again. Right. If I equals 1 and does not have to be an and or 2 clear Python 3. It's known. How come? It's 10, right? Okay, it's not returning anything, no? Return a 3 and 9. How come? 3 and 9, it is going to be 0. 5 7, great. In between those things, it's 5 7 and up to 30. Let's go up to 30. Isn't 19 a prime number? It is a prime number. But I'm framing the whole question wrong. Right, we will get a number. Here, right? It's not going to be a prime number. It's going to be f2, largest prime factor. Right. We will need to store that number as well. Let's just write this previous number equals to 0 for now. We don't need to assign it there. Previous number. This number, I number, is greater than ours is prime factor for, let's say, 13,195. It will have to be 29, isn't it? Right, so the number is there, number is there, but we are not going to use it. So while how many loops do we run? It will have to be an infinite loop, that's for sure. Largest prime number, right? So it will get that number for which we need factor for, and okay, I have an idea that I have in mind. I can simply do, let's run it up until not there but less than there. Let's find all the prime number first of all. Right, after that what we can do is, out of this list, right, so We find all the list first of all. What is it? What is it? That if it is divisible, we continue, otherwise no, right? We simply append I in this. Okay, the list is now ready, I guess. Right, the list is ready. Now, if prime number underscore list, right, if if prime number list, if the number percentage, if I percentage equals 0, at the very end we will need to return, right? But we will need to store that last value. Previous number equals to this I, right, at the very end I can simply return previous number. Is it going to work? Let's see. Clear. Problem 3, 0. Print prime number list. Okay, a lot of prime numbers, huh? A lot of prime numbers. Five, 7, 11, 13, 17. Okay. Print previous number. I'm returning it there now, that's why I will need to return it here. Nope, it should be somewhere there. Trapped. Euler. It's not remembering the number right for that stack. It's not remembering it. Why is this thing showing a problem? Should be int. I don't need this thing. Print I. We simply need to look at that first. Let's just have a view of it. Why are you giving me all this thing? Ah, I'm printing this thing. Oh, that's why. I don't need this. Paste down. None. How come, man? How come? Height divided by number. What am I doing? Number divided by I now. Should be something like this. That's when it will work, of course. That's just going to be the highest number. Nope. We'll have to store it somewhere. Previous number equals to be replaced by that I. Whatever that is going to be. And then when we return previous number. Previous number or highest number. Highest number. Great. So for this number, it's going to take a while, I guess. What am I doing anyway? I don't need even that list, right? So if the number itself is again divisible, we simply store that, don't need the list and everything, I guess. Get it to run, but it's just going to be too much. Without appending or anything, if I simply put this condition there, right? So I'm simply checking that thing there, and if I were to copy this thing and paste it somewhere there, shouldn't this thing generate a good answer? 1395. That's it. Or is it not doing that? But why are you printing that much? It's simply doing that. 693. Okay, let me make sure that I don't have this much code here. I don't use this uninitialized variable as well. I simply run this thing. It will take a while, I guess, so I will leave it running. Okay, let's run this in a terminal area, and at least let's list out the number of thing that can actually divide it as well, so that I know it's actually working. Whew, that's when you know Python is slow. How many digits is this? This is like what, thousand, million, billion, 600 billion. What are we here? 1, 2, 3, 4, 5, 6, 7, 8. It will take a while. Let's just duplicate problem 4.py. Right. Okay. One eternity later. Okay, I'll let it run, and then I will put in the solution after it has completed its computation. What's the next problem? Largest palindrome product. palindrome number reads both ways. Okay. We'll have to look in the digits place, I guess, in this question. Whew. Palindrome number. Product of two digit. Okay. Let's just copy the whole thing. Copy. Let's write it down somewhere here. Problem number 4. Paste. Control F. What we need to do is replace for the other one as well, slash P, and this is going to be question mark. Alright, replace all. Okay, that is done. Hash as object. Okay. So palindrome of multiple, it's going to return something. Palindrome multiple of 3, I guess. And is int. When it is 2, it's going to be a sum of 2-digit number, right? So it will have to be what? 0, 1 times 0 will not be considered. Okay, it will be 1 to something. Okay, 10. The only condition that I need to check for is 1010, right? 1010, it will have to be 0101. The reverse is also same, isn't it? digits are reversed. Okay, just need to check that. If str a equals what will be that? 10 10 10 10 will be 11, I guess. Right, I don't need the n for now. I need a this is on this thing. I deal with. So once I do string a and then I do that, will that work? Maybe. Won't. How come? Let's just see how much. Calculator. 10 times 11 will be 110. Okay. 100 times 11 will be 100 times 11 will be, what gets divided by 10 10 10 10 and divide by 10, 101. Okay, times 10. Alright, okay, now it should work. 101 times 10, 10 10. Right, so string a will be print a and print a time data minus 1. Should not just give out reverse. Is not subscriptable. Okay, str how is it? When we are looking at it, it looks like it's a palindrome. Oh, from the middle. We will have to think about it in a different way. So 2 times 2 digit number will be highest. Will it produce any third digit number? That's the only question. Will it produce that? It will produce 4 digit number. Will it produce that? Is 1 0 actually we will have to divide it by 2 and then we will have to compare. The string is there, right? So length of string divide by 2 and then from there you bring it and then you compare it with the front one. Right, so string a and then you do something like what? Length of it, length of a is 4, divide by how many? N, I guess. N will be 2 for this. Write 2 3, it will have to be divided by something, so just need to find its midpoint, and then after that what should happen. So up to that point only we should see. For the first one, okay, the length will be 2, I mean 4, true, so 0 and 1 will be checked. And for the other one it will be something similar, but we will have to do length a divided by n up to there. That should also work, right? Let's do this. Has no length a. Okay, let's just make this a string first of all. A equals to STRA. Too much hassle. Too much. String A. Length. Why is that not working? Then is coming right, and string is there. The length of that string will be midpoint. Should be from the midpoint. That's it. CP slicer. To do this, I guess. Hey, right. Midpoint. Oh, I'm starting to forget string slicing as well. Oh, that's returning that. It will have to be a int type, okay. It will be a int type, I guess. Right. Okay, bye. Okay, then. Good. That is fine. The checking part is easy. If validating whether it's a palindrome or not. But generating a list of it. So it's just going to be 2 loops, I guess. Right, something like for I in range, I don't know how much. Something we will need some length. we will need to work out that will it go above 3 digit or not. That should be validated first of all. Why is this problem still working? Is this the highest number? Otherwise it's taking too long. Not just prime number check. Oops, there is still one more number to go. Maybe it's my lack of memory. It's taking too long. Alright guys, I'll stop the stream for now because this might take a while. Until then, take care. Bye bye. So I'll update the answer as well in that once it is done. Alright, so it's a big number. Hopefully it will be done soonish.